In terms of the system, what we're trying to do is to actually make it easy so that no one actually really has to understand what it is that I'm going to talk about for the next 5 to 10 minutes. That's really the goal. Is we're trying to get people to be able to use something like, this is actually an older supercomputer that I used to run my dissertation. But all supercomputers look about the same. They're in banks and banks, and they have little blinky lights that show up, and they're in air conditioned rooms. And really, the goal of this is not necessarily to ever kind of touch that machine, but it's to actually make it do something useful. So we want it to analyze, simulate, model, visualize, or otherwise make sense of data. Generally, for us, it's going to be geospatial data stored on something like this. So this is actually the data store that was attached to that supercomputer. I mean, it's just rows and rows of hard disks and tape that allow us to actually store massive amounts of data and to analyze massive amounts of data. And the goal is to help people do this that have little to no experience. So we're not talking about people who have, taken an entire undergraduate curriculum as well as, some master's levels classes to do this. We're talking about an environmental scientist that normally goes out, and looks at tree rings and comes back and wants to actually do a bigger data analysis, right? We're talking about a social scientist that under normal circumstances doing surveys, but because of the pandemic had to pivot and now is doing some data analysis using novel data. So our target audience is undergraduates, 2-year students, graduate students, professionals, generally across the spatial, social, environmental sciences. So anybody who's kind of geospatial adjacent, as one of my undergraduate students put it. And, it's a big umbrella, so we're happy to have anybody for sure. But this seems to be kind of our target audience who we've really been able to reach. And the goal is to get them over this high learning curve. So one of the challenges that I've ran into as an instructor and as a researcher who does this stuff is the technical barriers. As soon as you say, okay, let's use this stuff, you're met with command line interfaces and something called batch queuing systems, and you have to be able to navigate the difference between head nodes and compute nodes and everything else. So the goal is to kind of not make that a complete brick wall, which stops learning, and to really lower those barriers and to kind of teach how it is that we can do that. And the goal of this is, or the system behind this is actually something called GI Sandbox. It's been a science gateway I've been actively developing along with Davide Del Vento and a number of other folks who have helped along the way. Kind of create a play space for people who work in geographic information systems and science to use these technologies. This is actually the system that Hour of CI sits on top of. That is a big enabler. And the big interface behind this is something we call Jupyter Notebooks, which I talked about in the last presentation. It allows you to run text and code and geovisualizations all in one document. And you'll get a little sense of that in the hands-on demo in just a few minutes. The big idea behind GI Sandbox is that it sits on a cloud resource called Jetstream, which is available from the NSF project called EXCEED, which stands for Extreme Science and Engineering Discovery Environment. They offer free compute resources to any researcher or instructor in the United States. I'm actually the GI Science domain champion. So if you have any questions about getting free access to supercomputers and compute resources, please send me an email. I'm happy to help people get up and going. And the idea is that we have these resources, but we need a way to access them. So GI Sandbox provides an interface using Jupyter Notebooks and an already existing environment of geospatial tools so that you can actually get easy access to this infrastructure. And this is kind of the idea behind this as a science gateway. So it makes it very easy to be able to do open source development. We're also working on getting ArcGIS on these resources, but that's a different workshop entirely. But if anybody's interested, happy to provide infrastructure support for these sorts of things. And Hour of CI or HCI lessons basically sit on top of this GI Sandbox environment and provide a presentation-esque format. So rather than the typical notebook view, what you're actually going to see is a set of slides that we actually just turn that notebook into a set of slides so that we can kind of frame and control what learners see in any particular time. It becomes a little less overwhelming. And what's interesting about these slides and these notebooks is that code is executable. So we can actually put inside the slides themselves executable code that people can develop, run, rerun. And this helps make it all interactive. Important for us, the results can be checked automatically, so we can actually turn them into assessments for learning. And this is something that we actually do. So behind the scenes, what ends up happening is that learners use these Jupyter slides. And again, you're going to try them in just a few minutes. And inside the slides, we have a couple of things. We have something that's called Jupyter widgets. So these are going to be your multiple choice boxes, your slider bars, and everything else. We have something called D3 widgets. So these are going to be kind of graphical interfaces that allow users to move things around. And then we have Python code that's either pre-written or the learners write themselves. And whenever the learners are interacting with those widgets, we're actually recording their interactions in a database using anonymized data collection. And this allows us to see, how is it that people are going through the lessons? How fast do they go through? Are they getting the answers right? How many tries does it take? And these sorts of things. And the Python code all runs on Jetstream Cloud Resource. So it actually has a little bit of oomph behind it if we get into anything that's really computational. So this is kind of the way that the system is set up. And the nice thing is that you actually didn't need to listen to the last couple of minutes that I was just talking, because the whole purpose of it was that you don't need to know what's going on. The only thing that you need to be able to do is go to hourofci.org, sign up, and use it. But if you're curious, there is a link right here to our GitHub page, which actually shows everyone. We've had a wonderful student, Iris, as well as Coleman, who have set up a kind of a walkthrough. So if you're interested in actually building this yourself on Jetstream, the instructions and the system information is all there and available for you. So people can actually build this themselves. If you don't want to use our infrastructure, build it, and you can do it all. So these are actually the instructions that I use to stand up our pilot interfaces and all of our other interfaces. So anybody can kind of follow it along. So if this is something that you're really interested in, take a look at Hour of CI system. It's all available. We're not trying to hide anything. And with that, I would like to thank you for listening, for kind of the intro or the introduction, and giving a little bit of background about the project, about the system that you're about to use.